The next problem is a long cylindrical piston of mass m slides smoothly inside a long cylinder closed at one end enclosing a certain mass of a gas. The cylinder is kept horizontal and it is disturbed from its equilibrium position. It oscillates simple harmonically, then period of oscillation capital T is option 1 T is equal to 2 pi root of m h by P A, option 2 T is equal to 2 pi root of m A divided by P H, option 3 T is equal to 2 pi root of m A h by P, option 4 T equals 2 pi root of m divided by P A h. So, dear students, let us understand the problem. So, what is the first statement? So, there is a piston of mass m. Okay, here, so this is the piston of mass m. It is moving smoothly on a very long cylinder of length h, and this cylinder is filled with certain gas. The mass is constant. The cylinder is kept is horizontal and it is disturbed from the mean position. Andartha eno? So, the initial position of the piston is here. The piston is slightly moves towards left. What happens? The pressure and volume of the gas changes. Imagine, let P be the initial pressure, V be the initial volume. Now, the piston is moved slightly towards left. So, what is the displacement? That is equal to x. So, now cylinder na piston na displace madidivi. What is the distance? That is equal to x. So, when the piston is released, it moves back and forth. That means, it exhibits simple harmonic motion. Our aim is to calculate the period of oscillation of the piston. So, what happens when the piston is moved towards left? Dear students, pressure and volume of the gas changes. The pressure increases by a value called dP, automatically volume decreases by a value dV. So, imagine the process is very slow, you call it as isothermal. Imagine the temperature of the system remains constant. The initial pressure is P, initial volume is V, final pressure is P plus delta V, delta P, and final volume is V minus delta V. So, PV or P1 V1 is equal to P2 V2. So, P into V is equal to, so P plus delta P multiplied by V minus delta V. Now, RHS ಅನ್ನು simplify ಮಾಡಿದ್ರೆ, so PV plus delta P into V minus P into delta V minus delta P into delta V. So, LHS becomes PV. Here PV get cancelled. The product dP into delta P into delta V is very small, that can be neglected, it becomes 0. Therefore, delta P into V is equal to P into delta V. The change in pressure delta P is responsible for restoring force. Imagine, let F be the restoring force. So, delta P can be written as force divided by area, that is equal to A, and volume of the cylinder or volume of the gas, initially it is the product of area into length, that is equal to H. So, the initial pressure is P, then the change in volume because of the movement of the piston, let x be the length and A be the area of cross section, it becomes A into x. Now, A get cancelled. So, F into H is equal to PAX, therefore, F is equal to PAX divided by H. According to force law, F is equal to Kx, that is equal to PAX divided by H. So, from this equation, the value of K is equal to PA divided by H. So, in the problem, the piston gets oscillates simple harmonic motion or simple harmonically, then the period of oscillation of the piston is given by T, that is equal to 2 pi into root of. So, the force constant is denoted by K and m be the mass of the piston. So, m divided by K, but K is equal to Pa by h. So, Pa, h goes to numerator, therefore, root of mh divided by Pa. So, T is equal to 2 pi root of mh by Pa is an expression for the period of SHM executed by the piston inside the cylinder. Therefore, from the given option, option 1 is the right option for this problem. The next problem is a simple pendulum with a metal bob has a time period of capital T. Now, the bob is immersed in a non-viscous liquid and the time period becomes 3T. The ratio of density of metal bob to that of the liquid is option 1 4:3, option 2 8:3, option 3 9:4 and option 4 9:8. Dear students, this problem is based on simple pendulum. So, statementally ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ಫಸ್ಟ್ ನೋಡೋಣ. So, simple pendulum with a metal bob. So, this metal bob produces time period is equal to capital T. So, we know the expression for time period of SHM, that is capital T is equal to 2 pi into root of L divided by G. So, what is L? Length of the pendulum. G, acceleration due to gravity at a point. ಹಾಗಾದರೆ ಪೀರಿಯಡ್ ಆಫ್ ಆಸಿಲೇಷನ್ ಯಾವ ಫ್ಯಾಕ್ಟರ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಯಿತು? ಸೊ ಲೆಂತ್ ಆಫ್ ದ ಪೆಂಡುಲಮ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿದೆ. ಹೇಗೆ ಡಿಪೆಂಡ್ ಆಗಿದೆ? ಪೀರಿಯಡ್ ಆಫ್ ಆಸಿಲೇಷನ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಸ್ಕ್ವೇರ್ ರೂಟ್ ಆಫ್ ಎಲ್. ಆಸ್ ದ ಲೆಂತ್ ಆಫ್ ದ ಪೆಂಡುಲಮ್ ಇನ್ಕ್ರೀಸಸ್, ಪೀರಿಯಡ್ ಆಫ್ ಆಸಿಲೇಷನ್ ಆಲ್ಸೋ ಇನ್ಕ್ರೀಸಸ್. More importantly, period of oscillation depends on acceleration due to gravity at a point. So, as acceleration due to gravity decreases, period of oscillation increases. Here, first half of the problem, so the simple pendulum is set up in air medium. Its period of oscillation is T is equal to 2 pi root of L divided by G. Next part alli nodi. Now, the bob is immersed in a non-viscous liquid. So, in the case of high viscous liquid, the oscillations of the pendulum dies out, then period of oscillation becomes infinity. Now, the simple pendulum execute simple harmonic motion even in non-viscous liquid. Therefore, this problem is based on the application of simple pendulum in a liquid. So, when the bob of the pendulum is immersed in a liquid, its time period increases, that is equal to 3T, the ratio of density of the metal bob to that of liquid. So, hagadre let rho 1 density of the metal bob, rho 2 density of the fluid or liquid, we have to calculate the ratio rho 1 to rho 2. So, why period of oscillation increases? ಇದನ್ನು ಫಸ್ಟ್ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಏನಾಗ್ತಿದೆ? So, when the metal bob immersed in a non-viscous liquid, the weight of the metal bob decreases. According to Archimedes principle, the operant loss in the weight of the body is equal to weight of the liquid displaced. So, ಹಾಗಾದರೆ ಈ ಕಾನ್ಸೆಪ್ಟ್ನ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋದ್ರಿಂದ weight decrease ಆಗೋದ್ರಿಂದ acceleration or effective acceleration due to gravity also changes. Therefore, acceleration due to gravity or time period of in the second case is given by T is equal to 2 pi root of L divided by G dash. So, G dash means effective acceleration, that is equal to G into 1 minus rho 2 divided by rho 1. So, G into 1 minus rho 2 divided by rho 1 is called effective acceleration due to gravity in a liquid. So, now you call this is equation number 1 and this is equation number 2. For this case, period of oscillation becomes 3T, therefore, it is 3T. Now, divide these two equations. So, T get cancelled, it becomes 1 divided by 3 So 2 pi cancels, L cancel, G cancel. Finally, in the denominator, root of 1 minus rho 2 divided by rho 1. So that goes to numerator. It is square root of 1 minus rho 2 divided by rho 1. So now take the square on both sides. What happens? 1 minus rho 2 divided by rho 1 is equal to square of 1 by 3. What is square of 1 by 3? It is 1 divided by 9. So rho 2 divided by rho 1 can be written as rho 2 by rho 1 is equal to 1 minus 1 divided by 9. So rho 2 divided by rho 1 is 1 minus 1 by 9. What is 1 minus 1 by 9? So that is equal to 9 minus 1, that is 8 over 9. So 8 by 9 is rho 2 divided by rho 1. What is rho 2? Density of the liquid. Rho 1 density of the metal bomb. Now problem alli ಏನು ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡ್ತಿದ್ದಾರೆ? Our aim is to find the ratio of density of the metal bob to the density of the fluid. So you take the reciprocal. Therefore rho 1 divided by rho 2 becomes 9 by 8. Therefore ratios of the density becomes 9 by 8. Therefore the right option is 4, 9:8. Dear students, this problem is based on the wave. The equation of a progressive wave is given by y is equal to a sine 2 pi into t by t minus x by lambda. The maximum particle velocity is 6 times the wave velocity, then its wavelength is. There are 4 options. Number 1, 3 pi a, option 2, 2 pi a, option 3, pi a by 3, option 4, pi a divided by 6. So questions in ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ದ ಇಕ್ವೇಷನ್ ಆಫ್ ಎ ಪ್ರೋಗ್ರೆಸಿವ್ ವೇವ್ ಇಸ್ ಗಿವನ್. ಅವರೊಂದು ಜನರಲ್ ಇಕ್ವೇಷನ್ ಆಫ್ ಪ್ರೋಗ್ರೆಸಿವ್ ವೇವ್ನ ಕೊಟ್ಟಿದ್ದಾರೆ. ಏನು? y ಈಸ್ ಈಕ್ವಲ್ ಟು a sin 2 pi t by t minus x by lambda. ಈ ಎಲ್ಲ ಟರ್ಮ್ದ ಮೀನಿಂಗ್ ನಿಮಗೆ ಗೊತ್ತಿರಬೇಕು. ಸೊ y ಅಂದರೆ ಏನು? ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಆಫ್ ದಿ ವೈಬ್ರೇಟಿಂಗ್ ಪಾರ್ಟಿಕಲ್. a ಆಂಪ್ಲಿಟ್ಯೂಡ್ ಆಫ್ ದ ವೇವ್. ಸೊ ಸ್ಮಾಲ್ t time, capital T period of oscillation, x the position of the particle, and lambda the wavelength. ಸೊ ಈ ಇಕ್ವೇಷನ್ನ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ನಾವು ಮ್ಯಾಕ್ಸಿಮಮ್ ದ ವೇವ್ ಲೆಂತ್ ಆಫ್ ದಿ ಪಾರ್ಟಿಕಲ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಈಗ ಕೊಟ್ಟಿರುವಂಥ ಯಾವುದೇ ಜನರಲ್ ಇಕ್ವೇಷನ್ ಇರಲಿ, ಅದನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಪೀರಿಯಡನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೋದು. ಇಲ್ಲಿ ಒಂದು ಪ್ರಾಬ್ಲಮಲ್ಲಿ ಒಂದು ಕ್ಲೂ ಇದೆ. ಏನು? ಮ್ಯಾಕ್ಸಿಮಮ್ ಪಾರ್ಟಿಕಲ್ ವೆಲಾಸಿಟಿ ಈಸ್ 6 times the wave velocity. So we know that particle velocity is different from wave velocity. So in the concept of oscillation, we know the formula for maximum velocity, that is, so V maximum is equal to a omega. So that is equal to 6 times the wave velocity, 6 into wave velocity denoted by V, but wave velocity is given by f lambda. So that can be denoted in terms of period also, that is lambda divided by capital T. But omega is angular frequency, that is equal to 2 pi by t. Therefore a into omega ಅಂತ ಹೇಳಿದ್ರೆ 2 pi divided by capital T, that is equal to 6 lambda divided by capital T. So here t get cancelled, 2 ones are 2 3s. ನಾವು ಲ್ಯಾಂಬ್ಡಾ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾಗಿದೆ. ಸೊ ಲ್ಯಾಂಬ್ಡಾ 3 ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡಿದ್ರೆ, ಸೊ ಲ್ಯಾಂಬ್ಡಾ ಈಸ್ ಈಕ್ವಲ್ ಟು ಎ ಇಂಟು ಪೈ ಡಿವೈಡೆಡ್ ಬೈ 3. Therefore the wavelength can be expressed in terms of amplitude, pi a or a into pi divided by 3. For this problem, option 3 is right option. Okay, let us read the problem. The wave pulses are sent to the bottom of the sea from a ship and echo is heard after 2 seconds. If the bulk modulus of water is 2 into 10 to the power of 9 Newton per meter square and density of the water is 1000 kg per meter cube, then the depth of the sea is option 1 1414 meter, option 2 707 meter, option 3 2828 meter, option 4 2000 meter. So, this problem is based on detection of depth of the ocean. So, with the help of sonar, sound, navigation and ranging. So, ಈ ಪ್ರಾಬ್ಲಮ್ ಏನಿದೆ ನೋಡೋಣ. So, there is a ocean, this is the surface of the water and this is the bottom of the sea. So, on the surface of the water there is a boat. So, inside the boat there is a source of sound. So, the sound from the source sent to the bottom of the sea. So, and this sound wave will reflect it back. So, the reflected sound is called echo. So, that reflected sound is received by the detector. ಹಾಗಿದ್ಮೇಲೆ, so if x be the depth of the ocean, then what is the distance travelled by the sound wave? That is equal to twice the depth of the sea. For example, this is the x, the distance travelled by the incident wave, and another x, distance travelled by the reflected wave. Therefore, x plus x, that is equal to 2x, that is the total distance travelled by the sound in a medium of water. So, this sound wave travel with a velocity v and time taken by the sound wave for this distance is given, that is equal to 2 seconds. So, we know the relation between velocity, distance and time, that is s is equal to velocity into time. So, s be the total distance travelled by the sound wave, that is equal to x plus x, that is 2x. What is v? Velocity of the sound wave in a liquid. According to Newton formula, velocity of sound wave in a liquid is given by root of b divided by rho. So, what is b? Bulk modulus of the liquid, rho density of the liquid, and multiplied by time taken. So, 2x is equal to root of bulk modulus of water is given, that is 2 into 10 to the power of 9, density of water is given, so 1000 kg per meter cube, that is 10 to the power of 3, and time taken by the sound wave is given, that is equal to 2. Here 2 get cancelled. So, denominator 10 power 3 there, numerator ತಗೊಂಡ್ರೆ it becomes 10 power minus 3, 10 power 9 minus 10 to the power of minus 3 becomes 10 to the power of 6, root ತಗೊಂಡ್ರೆ it becomes 1000. So, we know the value of root 2. What is root 2? So, 1.414 multiplied by 1000. What is 1.414 multiplied by 1000? That is equal to 1414 meter. So, that is the value of x. Here what is x? It is equal to depth of the sea. So, for this problem the answer is 1414 meter. The right option is option 1, that is 1414 meter. Dear students, this problem is based on Doppler effect. So, what is Doppler effect? The phenomenon in the operant change in the frequency of sound due to relative motion between source and the listener. ಈಗ source of sound ಮತ್ತು listener ಮಧ್ಯದಲ್ಲಿ relative motion ಇದ್ದಾಗ frequency of sound ಅಲ್ಲಿ ಚೇಂಜ್ ಆದಂಗೆ ಕಾಣುತ್ತೆ. ಇದನ್ನು Doppler effect ಅಂತ ಕರೆಯೋದು. ಸೊ ಈ ಕಾನ್ಸೆಪ್ಟ್ ಮೇಲೆ ಈ ಪ್ರಾಬ್ಲಮ್ನ ಫ್ರೇಮ್ ಮಾಡಿದ್ದೀವಿ. ಲೆಟ್ ಅಸ್ ರೀಡ್ ದ ಪ್ರಾಬ್ಲಮ್. A source of sound is falling under gravity at a time t is equal to 0. The detector lies vertically below the source at a depth 100 meter. If velocity of sound is 350 meter per second and true frequency is 1000 hertz, the operant frequency after 2.5 second is. Acceleration due to gravity is 10 meter per second square. There are 4 options. Number 1, 1000 hertz. Number 2, 933 hertz. Option 3, 500 hertz. And option 4, 1100 hertz. So, ಈಗ ಪ್ರಾಬ್ಲಮ್ನ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋದಾದರೆ ಸೋರ್ಸ್ ಆಫ್ ಸೌಂಡನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ. ದ ಸೋರ್ಸ್ ಆಫ್ ಸೌಂಡ್ ಈಸ್ ಫಾಲಿಂಗ್ ಅಂಡರ್ ಗ್ರಾವಿಟಿ. ವಾಟ್ ಡು ಮೀನ್ ಬೈ ದ್ಯಾಟ್? ವೆನ್ ದ ಬಾಡಿ ಈಸ್ ಅಂಡರ್ ಫ್ರೀ ಫಾಲ್, ಇಟ್ ಮೂವ್ಸ್ ಅಂಡರ್ ಗ್ರಾವಿಟಿ ವಿತ್ ಅನ್ ಆಕ್ಸಲೇಷನ್ ಈಕ್ವಲ್ ಟು g. ಸೊ ಎಲ್ಲಿಂದ ಫ್ರೀ ಫಾಲ್ ಆಗ್ತಿದೆ? ಅಟ್ ಎ ಟೈಮ್ t is equal to 0, that is called initial time, at a depth 100 meter above the detector. ನಾವು ಇದನ್ನು ಡಯಾಗ್ರಾಮ್ ಬರೆದು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋದಾದರೆ, ಸೊ ದಿಸ್ ಈಸ್ ದ ಸೋರ್ಸ್ ಆಫ್ ಸೌಂಡ್ and this is a detector. The distance between these two is given, that is 100 meter. So, the source is at this position at a time t is equal to 0 second. So, when the time increases, the source is moving vertically downward with an acceleration, that is velocity continuously increases. So, due to continuous increase in velocity, the operant frequency observed by the detector continuously changes. So, for the sake of this problem, we are going to calculate operant frequency particularly at one time instant, that is 2.5 second. So, imagine the detector is at an intermediate position at a time t is equal to 2.5 second. So, in this case, at a time 2.5 second, our aim is to calculate the velocity of the source. How to calculate velocity of the source? So, acceleration of the source is given, that is equal to g. So, time is given 2.5 second. So, how to get velocity? That is by definition, so velocity of the freely falling body initially at 0 velocity is equal to gt. So, this equation is arrived from v is equal to u plus gt, u initial velocity. So, initial velocity is 0 because source start from rest. ಇದಕ್ಕೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ the value of g is 10 meter per second square and t is given, so 2.5. Finally, we get 25 meter per second. This is the velocity of the source at an instant of time 2.5 seconds. So, at this instant, so this is the sound wave. It travels with a velocity v, that is also given 350 meter per second. The detector is at rest. Detector acts like a listener. Then the velocity of listener VL is taken as 0. So, ಈಗ ನಮಗೆ ಬೇಕಾಗಿರುವಂಥ ಎಲ್ಲ ಟರ್ಮ್ ಸಿಕ್ಕಿದೆ. ವೆಲಾಸಿಟಿ ಆಫ್ ದ ಸೋರ್ಸನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ವಿ 25 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್. ವೆಲಾಸಿಟಿ ಆಫ್ ಸೌಂಡನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ 350 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್. ವೆಲಾಸಿಟಿ ಆಫ್ ದ ಲಿಸ್ನರ್ 0 ಬಿಕಾಸ್ ಇಟ್ ಈಸ್ ಅಟ್ ರೆಸ್ಟ್. So, how to calculate operant frequency? We know the general expression for operant frequency, f dash is equal to f into v minus vl divided by v minus vs. Here vl is 0 and velocity of the source is positive. In general, f dash can be written as f into v divided by v minus vs. Here v is velocity of the sound, v is velocity of the source, that is equal to 25 meter per second. Equation is substitute ಮಾಡಿದ್ರೆ f true frequency ಕೊಟ್ಟಿದ್ದಾರೆ, that is equal to 1000 hertz multiplied by velocity of the source, velocity of the sound wave given, so 350 meter per second divided by 350 minus velocity of the source is 25. So, 1000 multiplied by 350, then what is 350 minus 25? That is equal to, so 325. So, on simplification we get 1076 hertz. ಈಗ ನಮಗೆ ಬಂದಿರೋ ಆನ್ಸರ್ನ 4 ಆಪ್ಷನಲ್ಲಿ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ದ ನಿಯರೆಸ್ಟ್ ಆನ್ಸರ್ ಈಸ್ 1100 hertz. Therefore, the fourth option is right option for this question. this is another problem based on same concept, that is Doppler effect. Let us read the problem. A circular table is rotating on its axis at 5 rotation per second. A source of sound of frequency 1000 Hertz is fixed on the table at 70 centimeter from the axis. The minimum frequency heard by the listener at certain distance from the table is given. Velocity of sound is 352 meter per second. There are 4 options. Number 1, 1000 Hertz. Number 2, 1066 Hertz. Number 3, 941 Hertz. And number 4, 352 Hertz. First problem analyze ಮಾಡಿ. So there is a circular table rotating on its axis at 5 rotation per second. ಈ ಸರ್ಕ್ಯುಲರ್ ಟೇಬಲ್ಲು 5 ರೊಟೇಷನ್ ಪರ್ ಸೆಕೆಂಡ್ ರೊಟೇಟ್ ಆಗ್ತಾ ಇರೋದ್ರಿಂದ ನಾವು ಫಸ್ಟು ಆಂಗ್ಯುಲರ್ ವೆಲಾಸಿಟಿ ಆಫ್ ದ ಟೇಬಲ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಸೊ ಇಮ್ಯಾಜಿನ್, ಸೊ ದಿಸ್ ಈಸ್ ದ ಸರ್ಕ್ಯುಲರ್ ಟೇಬಲ್ rotating about its own axis. So with 5 rotation per second, that is called frequency of rotation. So a source of sound is placed at a distance 70 centimeter from the center, that is called axis. So the source is observed by an observer at certain distance. Now imagine he is an observer. What happens? So listen here, the frequency of sound continuously changes. That depends on the direction of velocity of sound or velocity of source. So if the source is here, the sound travels in the direction with a velocity v, that is 352 meter per second. So here this is the direction of velocity of the source, denoted by Vs. If Vs and V in the same direction, the frequency of the sound heard by the listener is maximum. So if the source of sound is here, the velocity of the source is in this direction upward, it is less than this value. If the source is here, the source velocity is in direction that is equal to Vs. So if the source is once again in this position, it is moving downward. So there is a continuous change in direction velocity. So under what condition the person observe minimum frequency? That is, the direction of velocity of sound and direction of velocity of the observer is in opposite direction. So imagine when the source is here. So this is the direction of velocity of the source, denoted by Vs, and this is the direction of the velocity of sound. So when these two are opposite, the frequency heard by the listener is maximum. So at this position, so what will be the velocity of the source? ಈ velocity of the source ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದಕ್ಕೆ ನಮಗೆ ಫಾರ್ಮುಲಾ ಇರೋದು, we know that linear velocity v is equal to r into omega. So velocity of source is r into omega, that is given by r into, what is omega? 2 pi n. So n frequency of rotation. Therefore Vs is equal to, so r is equal to 70 centimeter, that is given by 70 divided by 100. So 2, we know the value of pi, 22 divided by 7. So frequency of rotation 5 rps, that is equal to 5. On simplification we get Vs is equal to 22 meter per second. Velocity of source ಗೊತ್ತಾದ್ಮೇಲೆ ಆಪರೆಂಟ್ ಫ್ರೀಕ್ವೆನ್ಸಿನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೋದು. ಆಪರೆಂಟ್ ಫ್ರೀಕ್ವೆನ್ಸಿ is given by f dash is equal to f into v divided by v plus Vs. So positive term because of source is moving opposite to direction of velocity of sound. Substitute ಮಾಡೋಣ. f is equal to 1000 Hertz multiply by velocity of sound is given 352 meter per second. So once again denominator 352 plus velocity of source calculated, that is equal to 22. ಇದನ್ನೆಲ್ಲ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ we get the value f dash is equal to 941 Hertz. Therefore For this question, option 3 is the right option.